So we start with the autonomic nervous system. So it's basically the same, right? It's the same nerves, the same generation of action potential, except look at our effector organs have no skeletal muscle. So the effector organs are the internal organs, your smooth muscle, your cardiac muscle, right? Your glands and your adipose tissue. Those are the effector organs. As long as it's not skeletal muscle, it must be the nerves that innervate that will be an autonomic nerve, okay? Do you understand? How do the autonomic nerves look like? It's the same thing. It still contains the dendrite, the cell body, the axon, except what? The effector organ is not skeletal muscle. So it's inside, right? My internal organs. Look at your internals. You have your lungs, your heart, your liver, your GI tract, all of those organs there. They can't do their job unless they are told by your nerves. Okay? And so that's the main difference. We always compare your somatic with the autonomic nervous system. Look at this picture. So, by the way, you compare them only in terms of the effector, the response, the motor response. As far as the sensory is concerned, you just call them visceral receptors, but it's the same ascending pathway. Okay? So all books always compare the two bodies, the two nervous systems, the two divisions, autonomic and somatic, in terms of the motor response. Okay? So do you remember? The somatic nervous system, this is your lower motor neuron, right? Upper motor neuron from the cerebral cortex to the level of the spinal cord, right? The ventral gray horn, and from there you have the lower motor neuron. This lower motor neuron, by the way, in your test for matching type, this is your ramus, right? This is the ramus. This is coming out of the ventral root. Okay, so that's why I know it's motor. So look at the main difference between somatic and autonomic. In the autonomic nervous system, the equivalent of the lower motor neuron is made up of two neurons. You see that? So two neurons, there's one neuron and there's another neuron. Two neurons make up the lower motor neuron equivalent of my somatic nervous system. Do you see that? Okay? And these two neurons, they meet at, I call it a processing site. This is a ganglion. Where cell bodies are found, you always call it a ganglion. Like this is called dorsal root ganglion, right? So this, wherever they meet, it's called a ganglion. Okay? Do you follow? So, the neuron before the ganglion is called the preganglionic neuron. This is the one. Look at where is it going to come out of? It's going to come out of the ventral root also. Yes, the ventral root. And then what is this ramus? Do you remember, if you look at your ramuses, this is your rami communicantis. Remember? So ventral ramus, dorsal ramus, the meningeal branch. Rami communicantis is the one that innervates my internal organs. This is the rami communicantis. And it's made up of two neurons, preganglionic and postganglionic neuron. The one after the ganglion is called postganglionic neuron. So let's look at this preganglionic. Look at the preganglionic neuron. Where is the cell body located? It's in the lateral horn of the spinal cord. Remember? Because the ventral horn, the effector organs are somatic. The lateral horn is the origin for your visceral effector neurons. Do you follow? Okay? So, this is my rami communicantis. So preganglionic neuron, the cell body located in the lateral horn of the spinal cord, and postganglionic, look at this picture. The postganglionic neuron, all of the neuron, cell body, the dendrites, and the axon is completely outside of the central nervous system. We compare them also, this one and this one, as far as the neurotransmitters released. For the somatic nervous system, there's only one neurotransmitter released, and that is acetylcholine. That's the only neurotransmitter for muscle, isn't it, right? And when you release acetylcholine, the muscle will contract. If there's no acetylcholine, it will not contract. Okay? Look at for your autonomic nervous system. In addition to acetylcholine, there is acetylcholine. Now, there's another neurotransmitter that I know you're familiar with. Epinephrine. Norepinephrine. Isn't this your stress hormone? It's called a hormone too. So, in addition to knowing them as hormones, now you also know them as neurotransmitters. They are part of the neurotransmitters released by my autonomic nervous system. So look at, I also have acetylcholine in my autonomic nerve, in my autonomic, same as this one. But in addition to acetylcholine, I have those epinephrine and norepinephrine neurotransmitters. Another difference between these two, with the somatic nervous system, right? When you stimulate muscle, it contracts. When you don't stimulate it, it doesn't contract, right? Here, in the autonomic nervous system, there is no such thing as contract, don't contract. It will, you know of the sympathetic, parasympathetic. Are you familiar with those two terms, right? Sympathetic and parasympathetic. And I know you know that they are opposing in action, right? Either sympathetic will increase, parasympathetic will decrease. But there's no such thing as contract, don't contract with the autonomic nervous system. So all my effector organs, my blood vessels, my heart, all of that, it will either, one, the sympathetic will either increase and the parasympathetic will decrease. You need to know that you cannot say that only the sympathetic increases activity and only the parasympathetic decreases activity. It depends on the effector organ. Okay? So we can say that. Just like in your, let's say in your blood vessels, sympathetic increases contraction. But in my respiratory system, sympathetic nervous system decreases or relaxes my bronchial muscles. So again, the response depends on the effector organ. Are you following? So this slide is just comparing the two, sympathetic versus autonomic. You see, don't forget, see the motor neuron pathway, the lower motor neuron is just one neuron, and then for the autonomic nervous system, it's made up of two neuron pathways. So again, the response, see, where is that? The sympathetic is your fight or flight, and the parasympathetic is your rest and digest activities. Okay? It depends always on the effector organ. And we differentiate between the two. So here it is. Now you understand this is your rami communicantis. So you see, there's a preganglionic neuron and a postganglionic neuron. It's the same root, right? Ventral root, and then it separates into ramus, ventral ramus, let's say, rami communicantis. Okay? And so now let's review the two divisions of the autonomic nervous system. There are two divisions. you have, one is the parasympathetic and the other one is the sympathetic nervous system. Okay. In my past test on the autonomic nervous system, I had a picture like this, and you tell me which one is sympathetic and which one is parasympathetic. Look at this picture. It's called sympathetic. Another term for sympathetic is thoracolumbar nervous system. Okay? And so look at the word thoracolumbar. It's telling me that the origin of my preganglionic neurons are from P1 to L2, L3. See? So always look at the cell bodies of the preganglionic neurons. Are you following? Again, my autonomic nervous system consists of two neurons, right? Preganglionic, postganglionic. Look at, in this picture, where is the cell body of the preganglionic neuron? Where is it located? I see them all coming out of P1 to L3. So if I don't see anything coming out of here, I will call this thoracolumbar sympathetic nerve. So this is my sympathetic nervous system. Okay? So in my sympathetic nervous system, I can also say that my sympathetic nervous system is made up of preganglionic neurons that originate from T1 to L3. That's it. And when they synapse with the postganglionic neurons, it is the postganglionic neurons that spread all over. You see that? Right? That's how they reach you, or they initiate a sympathetic response from head to toe. It's the preganglionic neuron that reaches from head to toe. Does it make sense? Okay? Okay? Then, let's identify our parasympathetic nervous system. Look at
the post that reaches, right?
Yes, it's
Okay,
the
you
post.
said pre.
Did I say pre? Oh, I'm sorry. It's the post. Sorry.
That's okay.
Look at this one. I can tell it's parasympathetic. I don't see them coming out of here. They're coming out of cranial nerves. You familiar? 3, 7, 9, 10, and S2 to S4. So craniosacral. So you see, parasympathetic nervous system. So the test, I remember, I had a picture and I asked the student, tell me which one is sympathetic and which one is parasympathetic. So very easy, right? Now let us compare. Let us compare the length of the I want to compare the length of this preganglionic neuron with the postganglionic neuron for each, the sympathetic and the parasympathetic nervous system. Okay? So look at the preganglionic neuron of the sympathetic nervous system. Look at it. The sympathetic nervous system, the preganglionic neuron is short action. Once it comes up, they're just showing this, it looks like it's big, but it's really right there. See? This, so as far as the sympathetic nervous system is concerned, the preganglionic neuron, which is short, okay, it will meet with the postganglionic neuron. It will meet with that one at several ganglia. So the ganglia, where do they meet? Where are these ganglia located? Number one, you call them paravertebral ganglia. So in the paravertebral, meaning on each side of the vertebral column. So look at, immediately when my preganglionic neuron comes out, it synapses with the paravertebral ganglia on each side. Immediately, right here in your, where's the, So here, if we look at our rami communicantes, right, the preganglionic, when they come out, again, T1 to L3, right, when they come out, immediately right here on each side, if you see that on each side right here, they already synapse with the postganglionic neuron. You call that paravertebral ganglion. Okay? Okay? So, on each side, right here. This, they're just moving it farther so that we can see it. But really, in the human body, this is very close there. That's why you call it's short in length. Okay? And so, this postganglionic neuron that come out of this one, they take care of innervating organs above the diaphragm. So what are the organs above the diaphragm? Can you give me organs above the diaphragm? Heart, what else? Lungs, all of those, right? You have your glands up there, you have your pleura, all of those organs above the diaphragm, you have the trachea, all of that. They are postganglionic neurons coming out of my paravertebral ganglion. So, this paravertebral ganglion, by the way, it's paired. One on the right and one on the left. Are you following so far, you think? Is it confusing? You got it? You think? So again, my rami communicantes is going to stimulate my internal organs. I'm just tracing these neurons. So this neuron, this is the sympathetic pathway. You see, it's the preganglionic neuron comes out and then it meets with a postganglionic neuron, right? They meet at a ganglion. The first ganglion where they can meet, you call it paravertebral ganglion. It's on each side. Okay? And the postganglionic neuron that comes out of that one, they take care of innervating organs above the diaphragm. Okay? Then, they can also synapse with the postganglionic neuron called the collateral. Or, no, maybe better for you to remember prevertebral ganglion. Pre meaning in front. Okay? So they can meet with the postganglionic neuron right there. And there's only one. It's in the center. So one set of ganglion, right? It's in front. Right here. And they take care, from here, the postganglionic neurons will innervate organs below the diaphragm. Like what? My stomach, my liver, right? My small intestine, large intestine, my pelvic organs. Okay? So did you notice? The postganglionic neurons are long for the sympathetic nervous system, right? Because my preganglion is right here. But then the postganglionic is the one that has to reach to the effector organs. So they're long compared to the preganglionic neuron. Okay? Okay? Then, there is a third way that they can synapse. This preganglionic neurons can also synapse with postganglionic neurons that is located in my adrenal medulla. So, the adrenal gland, from the adrenal gland, you will not see neurons coming out of it. This preganglionic neurons synapse with what you call the chromaffin cells of the medulla. And the way the adrenals respond, they release I know you know epinephrine and epinephrine. Epinephrine and norepinephrine. And where do these neurotransmitters go? They go into the blood. So you see, they are released into the blood. And so where is blood going? It's going to go from head to toe, right? So it's distributed all over the body. That's why sympathetic response is always generalized, right? Like if you're stressed out or you're scared of something, all of a sudden you break into a sweat, your heart races. All of those responses, you're breathing fast, it's a general response. Why? Because of this third synapse. Okay? Are you following? So, this is all preganglionic neuron, which can meet with the postganglionic. The headquarters is in 3 separate locations. This one is unique to the sympathetic nervous system. You don't find this in the parasympathetic. Okay? So compare the length, preganglionic, short for the sympathetic. The postganglionic is long for the parasympathetic nervous system. Okay?
The sympathetic nervous system, right?
It's sympathetic nervous system, yes. So where's the origin of this one? T1 to L2, L3. See? Now let's look at the parasympathetic nervous system. With the parasympathetic, look at with the so by the way, with the sympathetic nervous system, I know you've heard of this one. What do you call this ganglion? See? Look at mesenteric ganglion, your pelvic splanchnic nerve, all of these. Now you know when you hear the word mesenteric. Does it make sense? Mesenteric. Do you know where your mesentery is? It's here, right? So it must be my prevertebral ganglion. Now when you see the word splanchnic nerve, even when you go to the program, you see that splanchnic nerve, you should remember that it's referring to your autonomic nervous system. It's a visceral neuron. They're just trying to classify it in terms of the effector organ. It's not skeletal muscle. And so there are some neurons here that are part of your somatic neuron. Like let's say your sciatic nerve. So that sciatic nerve may have some axons that's innervating my sweat glands right here, right? I sweat here too. So it's part of the, so in other words, there are some neurons that are purely autonomic. I know this one has no skeletal muscle in it. So all the nerves that innervate this are purely autonomic. So I call them splanchnic nerves. Some are part of my somatic, right? And we know those, like median nerve, all of that, etc., etc. Now let's look at our parasympathetic. Okay. So with the parasympathetic nervous system, what do you notice with the parasympathetic nervous system? Look at this one. Of course, first of all, where's the preganglionic neuron coming out of? 3, 7, 9, 10, and S2 to S4. That's why I know it's parasympathetic. It's also known as your craniosacral nervous system. And look at the preganglionic neuron of the parasympathetic nervous system is long. It's the one that has to reach all the way to the effector organ. It's the opposite of the sympathetic. Did you notice that? Okay? And look look at where the ganglion is located for the parasympathetic. It is located in the effector organ itself. So that's why it's called intramural, meaning within the wall of the organ itself. Also, you can call it terminal ganglion. So that's why this is long in the parasympathetic. Because where's the ganglion? Right there in the effector organ. So look at the postganglionic, it is short because it's right there in the effector organ. So what is this telling me? It's telling me that the parasympathetic response is localized. There's the adrenal gland. There's no parasympathetic innervation there. You see? So all parasympathetic responses are localized. It's the sympathetic that's general. Because why? There is no epinephrine nor epinephrine released into the blood. Do you see that picture? Okay. So look at the ganglion. We don't see mesenteric ganglion, right? We don't see renal ganglion because there is no prevertebral. You see the ganglion, if you see this word ciliary, because you already know your anatomy, your bones, where is this? Up here in your head, right? Where's this? In your head. So I know it's a parasympathetic ganglion. Do you follow? What do you think? Everybody? Okay? So, you see why parasympathetic is what? Localized. You understand what this word means? Intramural or terminal ganglion. Okay? So what is the difference? It's just that it's two neurons involved, number one. Number two, the effector organs. There's no skeletal muscle for effector organ. And then also the response. There is no such thing as initiate, stop. There's no such thing for the autonomic. It's either increase, decrease. But there's no on, off. Does it make sense? For somatic, there is on, off. Here, no. There is either, what do you call it? Make it bright or dimmer. No off. Okay? So, the response of the effector organ, it depends on the type of receptors they have. Okay? And I'm not going to go into detail for that because it's too much for your brain cells. But you need to know, there are the nicotinic, have you heard of nicotinic responses, muscarinic, cholinergic? So it depends on the receptors of the different effector organs to the neurotransmitter being released. That's why I told you, I think your book, I forgot what page, but it's showing you the responses. You see, where is that? Sympathetic responses, you see, there's dilation of the pupil. So you see, this is pupil dilation. You would think it would be constriction for sympathetic. But it always depends on the effector organ. And then the parasympathetic, they just oppose each other. Okay? And of course, you also have your reflexes. This is what you call the visceral reflex. And it's made up of the same. Your sensory, then the motor. You can also classify it as monosynaptic, polysynaptic, intersegmental. But now, because the effector organ is your internal organs, you call it visceral reflex. That's it. And that's the end of your autonomic nervous system. It's very easy. Okay? So, break and we start with our mini pop quiz. But now we add one more person who came in. So instead of 2 people, what do we do?